everyone. We're going to find the dimensions of a rectangle with perimeter 100 meters whose area is as large as possible. In other words, we want to maximize our value of our area, and we're going to take the first derivative test for absolute extreme values. And we're going to find our critical number of our continuous function that is defined on the area. And we do that by taking the first derivative test. So let's look at what we have. We have dimensions of a rectangle. Let's let that be x and y. And then the formula for perimeter is 2x plus 2y equals our perimeter, which is 100 meters. I'm just going to put 100. If you divide everything by 2, we're going to get x plus y equals 50. And then solve for y. You get y equals 50 minus x. Now, what we're looking at is the area. So the area equals x times y. So in our case, that's going to be x times our y, which is 50 minus x, which we want to maximize. So I'm going to do the area of x. Our function is 50x minus x squared. Now, this is for our domain of x is in between 0 and 50. All right. So now we're going to find our critical number by taking the derivative. So a prime of x equals 50 minus 2x. I can go ahead and factor out a negative 2 if you want. You don't have to, but it makes it a little easier when we're going to test this. So that's going to be our derivative. Now what we want to do is maximize. So we want to say when our derivative, and instead of f, let's use a prime of x is positive, then our c, well, let's set this to 0. So our c is going to be 25. When you solve for x, that will be 25. So your critical value is 25. If I do a little line graph, that means we're going from 0 to 50, and then we have 25 here. So from 0 to 25, if I plug in, say, 23, that means when our derivative is negative, that means this is going to be positive, this is going to be negative. So if I plug in 26 into this, I'm going to get a negative number. So this is negative from 25 to 50. All right. And when a prime of x is positive, that's going to be from 0 to 25. Therefore, it does satisfy this condition, and that means a, because we have positive here and negative here. So positive means increasing and negative means decreasing. That means it's a maximum value if you drew the graph. So basically we do have, a does have an absolute maximum at x equals 25, and then we have to find the area. So the area of 25 equals 25 squared, and that's going to equal 625 meters squared. And if I plug it in, area, I just don't want to skip steps. So that's 25 times 50 minus 25. So this gives you 25. That's why I called it 25 squared. So the dimensions of the rectangle are 25 by 25. that means our rectangle is a square. And that's it. Thank you. Have a nice day. Bye-bye.